So this is what my workbench looks like when I'm working out a new project, and the premise for this project is actually this lovely tachometer. Not sure if you know it, but I love working with motors, BLDC motors, DC motors, all kinds of motors. I love them, and that's why it is important to find out how fast they're spinning. And so far I've been using this whole peak tachometer, and I've been using it for a couple of years now. I don't often measure the RPM, but when I do, it is kind of important, and I noticed that this thing doesn't work properly. It's just, the measurement is always off, and I will show that in the video. And the video is actually about me saying, I don't like this product, maybe we can do a DIY version which is way better. So this thing costs like 30 euro. And I did a couple of tests with the DC motor, which is a bit slower, and the BLDC motor, who goes up to 6,000 RPM. And in both cases, this thing doesn't do accurate measurements. As a reference, I will be filming this and this in slow motion, and then you can count how many frames pass before one rotation is done. So that is my precise measurement. And the funny thing is, I will build my own tachometer with this IR sensor, meaning with an IR LED and an IR photo receiver. So when the light from the IR LED returns, we got a small, I think, comparator here. I will have to take a closer look at the circuit, and it basically creates a square wave on the output whenever light returns, and then you get such a wonderful square wave signal on the oscilloscope. And I tried that, and it is really accurate. I was super surprised. This does not only work with small RPMs with the DC motors very well. I think I did 230 RPM, but it also works perfectly fine with the BLDC motor. For that I was like 1200 RPM up to 6000 RPM. So this thing is awesome for that. And now that I got all this testing done, and I know this is the way I want to go, I will see how I can connect that with an LCD, a microcontroller, and do some software, and then hopefully get a pretty accurate tachometer, which will probably be way cheaper than this and work 100 times better. But yeah, this is what I'm working on. It was quite interesting to do the measurements and find out how inaccurate this thing is. I'm not sure why. It seems like a promising product for the price tag, and it even got these adapters where you can add this to like have a contact measurement, and then it also got a laser, which you might think, yeah, laser is the way to go, that's more precise than IR, but apparently not. So yeah, look forward to the video. Well, this is what I'm currently working on. This will not come out in the very near future, but sooner or later, once again, a Tesla coil, as you can see here, will be a subject in one of my videos. Not especially the Tesla coil. I already did a video series about my own, which didn't work out that great. So for this new one, I actually got a kit from eBay from someone who does this all the time, so I expect very good results with this one. I will probably also talk about why mine wasn't that good, didn't work out that great, but I will see how this will turn out. So as you can see, very nicely done secondary winding here with tons of windings, all very neatly done. And then we got a proper top load. This one will be up here, as I would suggest. I will have to see how I will have to mount that. For that, he actually offered a very good manual. I just looked through that. That will be awesome for construction. And then we got the primary side, also very well done. Like I said, I think he sells those commercially, so he sells lots of them. They all work perfectly fine. I think... wait a minute, I got a picture here of what it may look like in the end. Yeah, so I hope for that. But for this, I will now assemble this kit. This is the PCB. It's a solid state Tesla coil, as you can read on it. And yeah, I will do that with the components which are included. And then I will see whether everything will work fine. I hope so. I'm certain it will work. And the point is then not using this PCB actually, because the video will be about gate drivers, and I think you can see that in the middle there, GDT, gate drive transformer. So the subject of the video will be about how to drive MOSFETs, and in this specifically it's about the gate driver transformer. How you can calculate that, how you can get commercial ones, how you can, and why you just use them. And I think it's a very interesting subject, and not sure if where the transformer is. Here. Sorry about that. That is his self-made one, as you can see, but it probably will work. I will have a look at it, and I will maybe compare it to commercial ones. Maybe, I'm not quite sure. I'm still at the beginning of creating this video, but it will be about gate drive transformers, and it will come out sooner or later. Really, this is just the beginning, but I thought it would be interesting to share this Tesla coil setup, and hopefully it will work out and you get a small clip of how it will perform. So guess what? The Tesla coil is finished. The assembly of the tower was pretty straightforward. Just insert the secondary coil into the primary coil, just push it in there, and then you got the primary coil here, and this is the feedback wire which will be used with this current sensor right here. So you just have to insert that there, and then the circuit can measure the resonance frequency of the circuit and tune it to that. So that is why it is a solid state Tesla coil, because it is working with this resonance frequency. And yeah, on top we basically just got a mechanical construction of spacers, and then this top load, and then more spacers and nuts and a wire which will be used for the sparks. And that's that. And I have to say, I really do like the construction of the PCB for this Tesla coil. Very well explained. You got all the circuits in the manual, so you know how this thing works, and it is well explained. And what I will do, not now, maybe later when I'm more into the production of this video, is test it out. Of course, I can hook it up to 230 volts, which I will not do in the beginning. I will try using an auto transformer to use a bit of a lower voltage and then see how it works out. But other than that, this is a very good construction of the driver circuit, and yeah, I'm confident that this will work out. So yeah, let's see how this project will continue in the future. As you can see, I ordered a couple of new components, and I thought I would just show you some interesting ones, I would say. Of course, I got the usual stuff of things which I destroy sometime, like alligator wires or jumper wires, or I use up DC jacks often, so these, or full bridge rectifiers or buzzers, like these are all just to keep my bins full. So whenever I need them, I have some laying around. So for example, those micro USB breakout boards I often use, a couple of ICs. I think there are some MOSFET drivers, some logic ICs, nothing special. And now this is, I think, the interesting stuff, the stuff that is left. Maybe I will do a video about this, or maybe not. It's always for idea gathering. And I also got this Electronical Mosquito killer, which just looked, I don't know, you just plug it in 230 volts and then it does something. So I thought this would be like a fun episode, maybe having a look at it, how it works, seeing if it's a death trap, which I kind of think it is. I will see how it works. So this was just for fun. And then I also got this cable tracker. I think that would also be an interesting subject. So I hope this works the way I think it does, because there's a product which does a similar thing. So what you basically do is, if you got wiring in your house and you want to see where does this wire go, you oftentimes do not have the privilege of having a proper wiring diagram in the walls or something like that, however it is called. And at that point you can basically hook up this wire tester, this first part, and then you can use the second part, which then picks up the signals which are injected into this wire through the wall, so you can basically see where the wire is. And that's a cable tracker. So I thought this would be interesting for maybe a DIY or buy episode. So seeing how it works and then creating our own. And then I got some stuff more. Those I think are pretty interesting. That's a 9-volt battery, as you can see, and this is an 18650. The interesting thing is it does have a micro USB port, so you can charge it up. So in theory, this is just a LiPo battery, which looks like an 8650 or a 9-volt battery in this case. Yes, this also has a micro USB input. And yeah, I think that's pretty smart, I think. Just having the form factor of those batteries and not actually the batteries, because you often, with those, you cannot recharge them oftentimes, and with those it is sometimes just easier to have this micro USB inputs to charge it instead of having a dedicated charger for that. So maybe again DIY or buy episode. And then just some stuff to goof around. This is a powerful H bridge, which I just wanted to have a look at. Then a valve electronically, maybe for the greenhouse part 3, not sure. A solenoid, yeah, I got this just for fun, I think. Not sure if I will ever use it. Then also those data loggers, maybe for a project where I will have to log some data, and using this instead of making my own save some time, you know. And then probably one of the most interesting things, that's an STM32F something board. And this is popular for MicroPython, I think. Yeah, it's even written on there, MicroPython. So maybe we can have a look at what MicroPython is, the language, and then use this as an example to see how easy it is in comparison to Arduino or other microcontrollers. And yeah, that's basically my whole order. So now you got an idea what might come or not. This is always for idea gathering. And yeah, I hope that will be interesting. So this is basically my latest project. I just finished it. Looks really nice, works really nice. And I actually asked on Twitter, Facebook, Patreon what you think this is. And just some people noticed that it is a guitar effects board. So yeah, there's my guitar. There's an amplifier. So the video will be about how to create electrically generated sounds and music. And first I tried to go the analog route, and you will see how that will turn out. And then I went with this Arduino route. So the premise of the video is basically I got this guitar. I've been playing guitar now for 4 months. I cannot do much, but I can play a song, and that's better than nothing. And it basically got a output. It's an electric guitar as well, so it can pick up this acoustic sound, and then it can output that. And usually you would just feed it into an amplifier like this. But for this project, I actually fed it into this board, into this box. And so let's see what we can hear. Turn it on. So this is the upper position when the LED is not on. In this case, the sound is basically passed through to the amplifier. I hope you can hear that. Works fine. Now let's turn on the effect. And yeah, we got some basic static sound now, but when we use the guitar, it got such an electric vibe. I think the effect is called Daft Punk, so it's an effect they used. And you can of course change the frequency by going higher. Or we can go lower with the push button. So yeah, it was a pretty fun project for me, and hopefully you will enjoy watching it too. It will come out pretty soon, I think. So here's a project I'm currently working on, which is practically taking forever. This is the last 3D print that I have to do. This is actually, not sure if you can see it, it is kind of like a tire. Not sure how well the design is thought out. I came up with it by myself, and yeah, it's pretty much, it's will be used for my electric skateboards. So these are like outdoor tires. When you want to have a little bit more grip, something like that, and it will hopefully fit on here. And I'm not sure about the indentations I created, whether those will help with better grip, better that the water can get out of there if there is too much water on the street. So not sure, this is pretty much an experiment, and like I said, this is not the first one, this is the last print. You can see actually the print quality improving. I think those two were the beginner ones, where the filament which I got, which is a TPU, I think it is a flexible filament, more or less, pretty much what car tires are made up of. Yeah, made up of. So it will hopefully have the same similar properties. And yeah, you can see here, I hope it'll work out because I don't have enough filament to do the whole print again. But you can see there was so many problems with the filament being too moist. You could actually hear how the water evaporates while printing. And so I put it in the oven, and that helped a lot. And for this third one, which you can see is a very big improvement, I actually tweaked a lot with the settings for the 3D print. So I finally got it done. The good one will be used for the wheel with the motor. So this one is important to have good grip, and this one as well. And the other two will be for the front, and I hope that'll work out. But that is just part one of the electronic skateboard improvements. Another improvement, if you've not already seen it, I think so, it is a mess down here. My lab is completely clustered at the moment with different projects. So I think I teased this before. This is a huge battery. It's not an 18650, if you're wondering. It's not sure what the size is. It's basically a lithium iron phosphate battery, so a nominal voltage of 3.2 volts, and it can hold 100 amp hours. And I have basically 4 of them in this package, so I will be having a 12 volt battery with a capacity of 100 amp hours, so that's 1.2 kilowatt hours, which I will put on my back. Hopefully, that is the plan. It's more like an experimental episode this time. And I plan to do this put this on my back, and then basically power this electric skateboard with it. And yeah, you should be familiar with this board. I made a video about it. Still works great. And then, because this can be quite dangerous, 1.2 kilowatt hours on your back, you definitely want some safety features. So I got good crimp connectors, fuses, a BMS, all that stuff. The boost converter, that will come. Maybe I will use that, not sure yet. I will have to do some testing. And yeah, then I also, in case you're wondering, I wanted to do some more high quality recording. I had an action camera, which was a pretty cheap one, so now I thought it was finally time to invest in something more, I would say popular. Not only popular, because of the name, but also because of its quality. So I hope this GoPro will capture some decent footage. And yeah, that is a mess of a project right now, but I hope it will be done soon. The printing will be done soon, so I can start testing, and you should see the video sometime, I guess. Oh boy, this has been one messy project so far. It actually looks just as messy because I did a lot of wire connectors, and I wanted to do them properly this time, like really properly, because as you can see, this battery pack here is massive. That is a 12 volts, no, 12.8 volts, 100 amp hours, so 1.28 kilowatt hour battery pack. This will be a small experiment with my electric longboard. That will be lots of fun. I hope it doesn't explode on my back. That would be quite terrible, but those are lithium iron phosphate, so they are safer than LiPo, and I'm not that scared actually. So, and here we got lots of connector stuff for crimping this time. As you can see here, I did lots of crimp connections this time. Here also with the boost converter that I will try to use. This will be an experiment whether this can power the longboard, because this battery pack, like I said, only has 12 volts, but we would like to have something like 24 volts. So this is where this comes into play. And here we got the inputs with 2.6 2.5 square millimeter wire, 2 on the plus, 2 on the minus, and then one big 6 square millimeter output here. And I will see whether that works. Just want to let you know that my workbench is a complete mess right now. But yeah, the hard part is now done with all the wiring, and now we can do the testing. So I just did a test, an experiment for my electric longboard, which I built, which still works perfectly fine, but I tried 3D printing outdoor tires, which, as you can see, are quite a bit bigger than the normal ones. And as you can see here, it did work. It improved the driving experience. Overall, it worked great on off-road, it worked great on bumpy roads, but in the end, yeah, you can see I should definitely print it in another way next time. It was just not stable enough. But other than that, this test was more or less successful. And another test I did was with the battery. I actually built a huge battery pack from lithium iron phosphate batteries, and that had 1.2 kilowatt hours. But the thing is, it was only 12 volts. So my idea was to boost it, but then I could not brake, and I really didn't want to risk that. So in the end, I tried using 12 volts directly, and the wheels turned, but the power was just not enough to transport me. So that was a huge fail, but I will talk about that in the video. And yeah, not the most successful experiments, but I want to try them out. I think they are pretty interesting, so look forward to the video.